The following video is an excerpt from Aqua Excel's online training course, Start Your Career in Water Treatment. For the full course, and many others like it, please go to www.aquaexcel.com. Water, water everywhere, nor a drop to drink. That's from the rhyme in The Ancient Mariner. That quote sums up why we treat drinking water. You can be in the middle of a crystal clear ocean and still die from drinking the water because it contains properties that our bodies don't like. As operators, we need to know how to spot the problems and, more importantly, prevent them from happening in the first place. This section is about why we treat water and some basic treatment techniques. Water systems should always be designed with this multiple redundancy approach. Safeguards are essential because no single barrier can completely prevent water contamination. You need something in place in case one method fails or something unexpected happens. This is what the term conventional water treatment means in Ontario. Starting at an intake screen or well, the raw water is dosed with the proper amount and type of coagulation chemical, then rapidly mixed, and then slowly mixed in the coagulation and flocculation process. Solids are settled out in clarifiers, and the water is again filtered. Primary inactivation is added, and the disinfection contact chamber gives the chlorine enough time to work its magic and inactivate the pathogens. A second shot of chlorine boosts up the water's disinfection levels for the distribution system, and it's on its way to your tap. A direct filtration process is mostly the same as a conventional treatment, but it's missing the sedimentation step. It has chemically assisted filtration, meaning it has the coagulation and flocculation, but it is a simpler system meant for smaller plants with lower flow water needs. Filtration. There are three basic types of filtration. Mechanical, where the unwanted thing or things in your water are physically caught in something and removed, like fish in a net. Biological, as in sewage, where microorganisms convert bad things into something better. And chemical, like when you use coagulants such as alum to convert the molecular bonds of phosphorus and make less harmful molecules that can be removed in a whole new way. But basically, when people talk about filters, they're talking about the mechanical filters, and this is what the filter in a conventional water treatment process is. It's a mechanical filter that physically catches the flock we made in the coagulation and filtration process, and any flock that got through the clarifier. Because the clarifier will do the bulk of the work, the filter in a conventional treatment system may be called a polishing filter. Filters can be upflow, where the water flows up from pumps through them, or gravity, where gravity pushes the water down through the filter. The most common type is the rapid sand gravity filter, or rapid rate filter. They typically contain layers of anthracite, sand, and gravel, although sometimes when taste and odor are issues, granulated activated carbon, or GAC, may be used instead of the anthracite. We can electronically measure the effectiveness of a filter by the turbidity of the effluent. A raise in turbidity means the filter is less effective and needs cleaning. Most filters are cleaned by reversing the flow of water through the media inside to suspend it a bit and allow spaces for the collected particles to be washed out. The backwash will contain sludge that can be further treated in a wastewater treatment plant. Filters like this have been around since the Stone Age and aren't going anywhere soon because they are cheap, simple, and easy to maintain. But lately, as more and more plants become landlocked, space is an issue, and membrane technologies are rapidly becoming cheaper and more efficient in a smaller space than their sand and gravel counterparts. Membrane filters are more complicated, but typically employ a cross-flow filtration process that essentially skids water across a filter so the big stuff builds up in a loop and the small stuff goes through an incredibly small hole. Some membranes can filter bacteria and RO can filter molecules. See if you can drag and drop the conventional treatment step title to its correct picture on the next slide. If you get stuck, click on the bottom for a hint. The preceding video contains small excerpts from Aqua online water treatment course, Start Your Career in Water Treatment. The actual course contains multiple interactive games and quizzes and cannot be properly represented in a video. To try a free, fully interactive sample of our mobile-friendly courses, please go to www.aquaexcel.com. Thank you for watching.